Carbon. Carbon. Our bones and bodies would not exist without it. Neither would plants or microbes, or the incredible carbon chemistry that links us all together. Carbon is the stuff of life on Earth. And it is old. Carbon was forged in the nuclear furnaces of long-dead stars before our solar system was even a wink in the celestial eye. Right now, about 1 trillion tons of carbon are bound up in living organisms. But far more is locked away in the fossil fuels, like coal, oil, and gas, and in the very rocks of the Earth deep underground. Back in the mid-Jurassic, the Earth was a dinosaur-inhabited world on the move. The continents, once joined together, were now breaking up. And the sustained volcanism pumped huge amounts of carbon into the atmosphere. One day in the future, this warm equatorial seascape will become the oil-rich deserts of the Middle East. But now, the sea is rising, and so are the temperatures. Both the atmosphere and the oceans are loaded with CO2. Trillions of these tiny plants swarm near the surface, all soaking up the sun and sucking in CO2. Inside this cell, our carbon dioxide molecule is transformed into an energy-rich sugar via the flash of a prehistoric sunbeam. As a means of capturing solar energy and storing it for later use, photosynthesis is unbeatable. The cell divides and divides again. Sunlight and carbon dioxide are being harvested and squirreled away into organic cell walls and fatty carbohydrate molecules. The whole Tethys Ocean is blooming with phytoplankton. Fast forward to our modern world. The individual algal cells in a phytoplankton bloom may be microscopic, but en masse, you can see them from space. Giant green swirls appear in places where plant food is concentrated by winds, currents, or rivers, or trapped by restricted circulation. Almost 1,000 feet below, perhaps the most fertile region of the ocean today, the water is anoxic, totally devoid of oxygen. A steady rain of dead plankton cells has accumulated into a thick, quivering, uneaten, black organic ooze. And another step on the long road to an oil deposit is complete. Many petroleum source rocks accumulated in these very unhealthy, very stinky seas of the Jurassic Middle East. As sea monster and plankton cells alike settled down into the inky depths below. This dead zone stretched as far as Western Europe, and it was this muddy graveyard that would become the most important source of crude that the world had ever seen. It was an enormous plankton bloom in the bath-warm waters of the Jurassic Middle East that led to a dead zone so immense it reached as far as Western Europe. And it was here that our petroleum source rock began to accumulate.
The oceans then were just replete with organic matter. These microscopic plants proliferated in quantities that the world hasn't seen for millions of years. And they were also able to be preserved because these oceans were very prone to stagnation. So there was much less oxygen in the water, much less overturning of the water. The organic matter would sink to the bottom and be preserved, and then it would be buried by rapidly accumulating sediments. When it gets to a certain depth of burial, some thousands of feet below the surface, it's physically cooked by the pressures and the temperatures you get there, and the organic carbon cracks and goes from this original material to light, sweet crude, as oil people tend to call it.
The temperature is critical. The deeper you go, the warmer the earth. Bury the shale too far down, and it is overcooked into natural gas. Too shallow, and you end up with a half-baked greasy oil shale. Deep below Saudi Arabia, the conditions were just right. Of course, the Earth did not stay still while all this happened. The continents continued to break up and move. Mountain ranges rose and fell. Seas evaporated and then returned. The face of the Earth changed completely. Around 15 million years ago, the Tethys Ocean finally closed up as Arabia collided ever so gently with Eurasia. 3 times during the reign of the dinosaurs, once in the Jurassic and twice later in the Cretaceous, thick black shales were laid down in the Middle East. So many that 2/3 of the world's oil supply comes from organic sediments buried here.
In Saudi Arabia and Kuwait and the 5 main Middle Eastern states, there were really singular conditions. You had a number of things that absolutely are required for giant oil fields. Really rich source rocks from which the carbon can be cooked at the right temperatures and pressures underground. Really excellent reservoir rocks where the oil can migrate through the microscopic pores and be trapped in these reservoirs. Most people don't realize this. They think you can find oil anywhere. The vast majority of the planet is actually devoid of oil because these special conditions are not met.
When Edison switched on his electric light bulb in 1879, he simultaneously switched off the demand for kerosene. The emerging big new oil monopolies like J.D. Rockefeller's Standard Oil Company needed to find a new market for the crude flooding from their wells. And it didn't take long to find one. It was the internal combustion engine, and it had a thirst for a waste product of the kerosene business: gasoline.
The automobile came along roughly 1910, and by 1920, Ford was mass-producing automobiles, and this was when my mother claimed that the world changed for them, that the farm and the people who lived on the next farm weren't the horizon anymore. She went away to college.
By the early part of the 20th century, the oil genie had been unleashed onto the world, and as the price of crude fell, gasoline-fueled vehicles became the most competitive form of transport. Electric tram companies were bought out and the tramways dismantled. Bike paths were abandoned, and governments were persuaded to build paved roads and highways for cars.
Before we knew it, we'd all moved out to the suburbs, we were all getting completely addicted, and we were designing economies built around this stuff. Every sector of every economy